Good evening, everyone. Shiny from Mydbops here. Thank you for joining us today for the 42nd edition of My Webinar by Mydbops. Today, we will be exploring scaling TiDB for large scale applications. TiDB is a powerful distributed SQL database designed to handle massive amounts of data. It offers seamless scalability, high performance, and reliability, making it an ideal choice for businesses experiencing rapid growth. And we are very honored to have Kabilesh P.R with us. He is a founding partner at Mydbops. Kabilesh is passionate about open source database technologies and has extensive knowledge of TiDB, MySQL, and distributed SQL systems. He is a well known tech speaker and blogger in the database community. And notably, Kabilesh is India's first Pink App certified TiDB professional and an AWS database specialist. With his vast experience, he has helped many organizations overcome challenges in scaling, performance tuning, and database migrations. In this session, Kabilesh will share insights on how enterprises have successfully adapted TiDB to support their high workloads. And everyone, please feel free to drop your questions in the comment box during the session and we will address them immediately. Let's get started. Kabilesh, over to you.
Thanks, Aini, for the warm welcome and introduction. So, our today's topic is scaling TiDB for large-scale application. So, empowering scalability and performance with simplicity. How enterprise achieve this? And my name is Kabilesh P.R. I have around 13 years of experience handling databases for large enterprises like Flipkart and many others. And I'm one of the founding partner of Mydbops, who is into database support. And this is the QR code which redirects to my LinkedIn page to know more about me. Okay, this is Mydbops. This is about Mydbops. So we are a trusted open source database partner with around 8+ years of experience and expertise. Mydbops, this is Mydbops number. So if you want to know, like we are on 8+ years company handling 800+ happy clients and DB transaction. We are handling more than billions of transaction and 6,000 servers are being actively monitored and supported by our support team actively. And these are the technologies what we support. It's MySQL, Mongo, Postgres, MariaDB, TiDB, and Cassandra on their open source version with in a cost-effective manner. And this is our service model. So we provide two service models. That is a targeted engagement, which is consulting, or which is based on mandates and project basis. And next is a managed services, which is your remote DBA services 24/7, assisting your database in your production environment. Focusing on this again on these database technologies, MySQL, Mongo, Postgres, TiDB, and Cassandra. Okay, so this is our agenda, like why enterprise choose TiDB for their scaling their production environment. Okay, and these are some of the biggest enterprises who are best in what they do. For example, Flipkart, that is being the biggest e-commerce in India. Book My Show, handling a large number of traffic for Pushpa 2 or whatever the shows that comes in together, deliveries into logistics, Paytm, Databricks, LinkedIn. LinkedIn is again a social media company. You know about the professional, it's a professional media where people collaborate and do everything. Bolt, again, it's a uh, uh, car rental and services, etc. So what is common between these enterprises is they were using MySQL for various workload. Because of those issues, they are now recently migrated to TiDB. Okay. Now we will discuss about what are these compelling features that had made these enterprises to move towards TiDB for scaling their databases. Okay. So the first important thing is the MySQL scalability bottleneck. It all starts from here. So the MySQL as a database comes with a shared nothing architecture. That means it does not provide horizontal scalability capabilities with respect to the data sharding. That means on the fly horizontal scalability is not possible, and it always comes with a vertical scaling limitation. That means when you are you might people can relate to it. For example, when you are running a MySQL server, when your application scale or the incoming traffic increases, the first thing they do is they just increase the server size. That means they upscale the instance with respect to the RAM, CPU, and IOPS to bring in the scaling. So that is a vertical scaling limitation. It has a limit. For example, even with the biggest cloud providers, maybe it AWS, GCP, there is always an upper limit for the machine type which you can spin for your application. Maybe it's a database or any other use case. So that is where the MySQL, the first MySQL scalability bottleneck is hit. And next is a schema change limitation. Okay. So for example, let's consider you have a table of around 2 terabyte. Okay. So what will you do to do a index addition to that will help in your application release? Okay. So you have to wait for that when you run a DDL, the table will get locked. That means the index addition table will get locked, and you have to wait for the or you have to take a downtime specifically in a late night, or you have to use a third-party tool such as PT Online Schema, which again comes with its own set of limitation. You have to have a similar set of size. That is, if you have a 2 TB table, you have to have a 2 TB free space, and performance hit will be there, some triggers and a lot of things is involved in it. And next is the read scalability issues. Okay, so MySQL supports asynchronous replica. Maybe it's a master or replica architecture, or even with the InnoDB cluster, the replication is not synchronous. Maybe it's a virtual synchronous, but at the end of the day, it is asynchronous in nature. This can cause replication delays and inconsistency in the read scalabilities. Okay, and the last and final point, the major point, is the write scalability issues. Whether it's a master or a replica architecture or it's an InnoDB cluster, it is always recommended to have a primary writer. That means in all the cases, the writer will be always a single node, leading to single write scalability bottlenecks, and also a single point of failure when it comes for high availability of the master. Okay. So next, we'll discuss about how this scalability issues is addressed by TiDB. So TiDB comes with the architecture which is completely scalable. For example, if you see in this architecture, there are three main components. One is a TiDB, the other is a PD cluster, and other is a TiKV. So each component can scale individually. So TiDB is your SQL layer, PD is your metadata manager, and TiKV is your row-based key value pair, highly scalable storage layer. Okay, so they intercommunicate with each other. Okay, with the gRPC protocol, forming this entire TiDB cluster. Each component can scale individually, horizontally as well as vertically. So that is how TiDB addresses this scalability issues with when it comes to when you have faced some MySQL scalability issues, and this TiDB is completely compatible with MySQL protocol. Okay. We'll see the next thing. So next important thing is, so yes, now you have chosen the scalable database, that is TiDB. Now, what will be the migration? So what will be the migration pipeline to handle these things? Okay, so migration is very much easy when it comes to MySQL for migrating from MySQL. For example, you have a MySQL server running. TiDB can directly act as a replica for your current MySQL. That means, so TiDB provides a DM, so this data migrator toolkit, which is available in open source. You can define the task. So the task contains the source that is your source MySQL and your destination TiDB. You create a task file and you start the migration. This is the flow of migration. First, the migrator takes an initial seed backup from the MySQL by using MyDumper. So their version of MyDumper in a multi-threaded fashion, and it is stored as a SQL files. And the SQL files are again then loaded to your destination, that is TiDB. And once the loading get completes, that the initial loading get completes, it takes the binlog position from the point of backup and create a replica. That means it will start a binlog dump thread from the source and syncs the incremental data. So this is how the migration pipeline works from MySQL to TiDB. So we are sorted on the migration. Migration is running. And next important question, what the enterprise asks is, what will be the operation overhead by using TiDB, and what are the other features? Maybe it's a backup. So TiDB comes with a detailed answer for this. For example, cluster management. The first thing is how much resource is needed to handle this entire cluster. That means the fleet of the various components such as PD, TiDB, or TiKV. So the cluster management comes in a very simplified way. That means from a central management node, that is a component called TiUp, which is installed. from which you can control the entire cluster, even the installation, the restart of cluster, adding a node, removing a node, downscaling a node is all handled at a central place. Not that you need to log into each component individually and do that. And also the other components, for example, backup can also be installed via tie-up. The CDC component, the ecosystem of components is all installed by the tie-up itself. And again, the ease of operation comes again. We have already discussed this online DDL. In TiDB, the DDL is completely online. That means even when you add an index or add a column, everything is instant. It's not instance. It will be like non-blocking and non-locking. And you can also, this TiDB also provides a feasibility to pause your DDL. For example, let's say someone accidentally started a bigger DDL in a non-intended time. You can just log in and pause this DDL and then resume later as well. And it comes with the purging, automated TTL based purging, which helps in the management of the data lifecycle, and auto rebalancing. For example, when you add a new node to the cluster via tie-up, the balancing and the data chunk movement is automated and it is managed by the PD itself. And zero downtime upgrade. So for example, this is one of the important things. When you have a application, that a database application, patching is very crucial to maintain the security features or the features to abide the new features and incorporate into your release cycles. So TiDB comes with a zero downtime upgrade. That is a real zero downtime upgrade. That means even your connection, for example, in a typical scenario, you might be having a load balancer on top of your application. So when you do an upgrade, the ongoing connections from the load balancer will get reconnected. That means there will be a connection reconnect when the underlying application, that is database, restarts. Here, by using type proxy, that um, even the connection is persisted and it is failed back to the available TiDB instance during a rolling upgrade. Thereby, real zero downtime upgrade is achievable. So we have tested this and we have also done a detailed demo in our YouTube channel. You can visit that. And the next important thing is MySQL syntax support. That means, for example, when you are moving from MySQL to TiDB, there is no change in your development lifecycle. Whatever the code which is active in MySQL can directly speak with the TiDB because it is protocol aware. And distributed backups. So next important thing what that enterprise asks for is a backup, whether the TiDB supports backup, recovery, point in time. It's all supported with BR. So BR is a backup and recovery tool. It has capabilities to directly upload to the S3 and also locally in a shared drive such as EFS, etc. And auto failover. Another important thing is auto failover. When it comes to MySQL, it comes with a single master bottleneck. Whenever there is a failure in master, it has to be failovered automatically or by a third-party tool such as orchestrator or something. But in TiDB, the failover is completely automated. It comes with a highly available wrapped protocol. Even the end user or the client will not know that you have failed over. Okay? So these are the important operation and development overhead which is taken out by using TiDB. So, and this is one of the main reasons for enterprise choosing TiDB as their database for their database workload. And the next important thing is observability and alerting. So how the observability is important when you handle a data at scale. For example, what my database is currently up to. What if there is a small glitch or there is an outage that needs to be immediately means seen by our support engineers and acted upon immediately to reduce the means blast radius. So TiDB provides a comprehensive monitoring by using tie-up itself. That means the same component can also be used to install the monitoring stack. The monitoring stack consists of the Grafana for dashboards and Prometheus, which is your time series data collector, and Alert Manager, which is integrated for the alerting. And also, one more important thing is TiDB also provides a comprehensive dashboard called PD dashboard. So that's a very powerful tool. In the PD dashboard, you can see the real-time queries which is ongoing in the cluster, the slow queries, the cluster state, and also some graphs. So it is a very beautiful tool. I really enjoy using the PD dashboard for my day-to-day operations. Okay, and this is small snippet of the Grafana dashboard, what it provides. So there is lot number of dashboards, specific dashboard. This is an overview graph, which I mostly use for the production workload, which is a single pane of observability for all the components like PD, TiDB, and TiKV. Okay. The another important thing is now as the world move towards a data oriented mode, like using the data, how fast you can take your decision, that defines a company which is going forward or which is lagging. So for example, TiDB as a MySQL does not support real-time analytics. Okay, so to achieve the real-time analytics in your traditional databases, for example, whether it's some Postgres or whatever it is, so you have to move the relational database through a ETL pipeline to a columnar database such as an Redshift or a ClickHouse, and then you have to power up your ETL tools or your Power BI tools or reporting tools to get the real insight out of it, and then lot of operations. There is a lot of operations involved in maintaining the ETL pipeline, reverse ETL, and the engineer's effect is very much higher. On the other hand, TiDB is a htap database. It supports both transactional and analytical workload. It supports a real-time analytical workload with the help of TiFlash, which is a columnar storage, which is again replicated directly from the raw format, that is TiKV format, so that the replication and the data is in near real-time sync, thereby directly powering your reporting or your ETL workload. And also this minimizes the operational overhead of engineers maintaining the TiDB. Okay, so again, that's all the compelling reasons that make enterprise to choose TiDB. And we'll also discuss about the growing community, what TiDB provides. Okay. So TiDB is completely open source, and you can see the number of stars. So TiDB is one of the most starred or the second most starred database project next to ClickHouse, and it has worldwide global contributors. And TiDB has a very vibrant and active Slack community, which has around close to 6K followers, sorry, 6K members. Even a small doubt, for example, I am a part of this community. For example, if there is a question asked in the community, it is answered immediately, which is very great. And also, if you provide a bugs or which is being actively acted upon by the community and it is transferred to a Git ticket, and I'm really grateful for the TiDB community for providing active bug fixes and patches. And recently, TiDB also has launched an TiDB.ai, an interactive Gen AI platform from the website itself. And you can ask your questions, it provides immediate results. Now let's discuss about the real world use case. That means I'll discuss some of the 3 case studies what I have personally done with MyDBOps with open source TiDB. Case study 1. So this customer you might have known, so the Yulu. So you might have seen Yulu bikes around Bangalore. The delivery guys mostly use them for their day-to-day delivery operations. So let me explain the problem statement for Yulu. So Yulu was using MySQL RDS specifically, wherein they had a huge size of data. That means the data set size, the storage size was around 41 terabytes, comprising of both transactional and log data. The log data is nothing but it's a each Yulu bike has a device called IoT device that sends information back to the grid, like their journey information, their battery information, what is the distance traveled, whether it is in a resting period. So those multiple health information regarding to the bike is being sent. So that is the log data. So comprising it, the log data alone comprises around close to 18 terabytes of data along with the transaction data. What happens is when this log data comes in bulk, so they have around 70 to 80,000 bytes on the road. Each bike sends data approximately for every 5 seconds. Okay, consider the scale which is being handled. And as this data is hosted along with the log data plus transaction data, when this log has a high volume of write, okay, it's basically write intensive. And when it comes, it completely stalls the RDS. That means they have to take a reboot or fail over to the other available AZ and then to bring up and it was affecting the uptime of the system and also experience of the app. Okay, so write were completely bottlenecked, large, and for example, they had some bigger tables in the log, crossing more than 3 terabytes or 4 terabytes when they do a DDL operation like an index creation for a new release or something like that. So they had to wait for 3 or 4 days for this operation to complete and increase database cost. Obviously, they had to scale the upscale the databases every time and maintain the uptime. So this was their problem statement. They came to us and we suggested them to do a POC and testing on the TiDB. So we created TiDB as a direct replica for the RDS, and we migrated all this log data. That means 18 terabytes of data was completely moved to TiDB with a live replication from MySQL. And they started to create a dual write channel. That means from the application pipeline. And post completing the POC, they migrated and they cut over all this log data to complete TiDB. The results were very much astonishing. I'll just share the result. Seamless horizontal scaling. So, for example, in previously when they have to scale the MySQL, they have to just upscale. Now it is not the case. They just need to add a node, and that's all. The scaling is done automatically, and the distribution happens. The read distribution and the write distribution is very much seamless. That means the write handling is handled by multiple nodes. In TiDB, the write is handled at a region level. That means the writer is distributed among all the nodes, and also storage saving. This is one of the important things. So 18 terabytes of data in MySQL was translated to just a 3.4 terabytes of data, which is around 72% of saving on the storage, thereby drastically reducing the infra cost which is spent on the storage, and also reliability again. So for example, even if there is a node failure or an complete AZ failure, the TiDB can withstand without any issues. Next is a case study too. This is a very interesting case study. This customer is on Aurora. So if you think of Aurora, you might know the cost. They were on the biggest form of Aurora. They were on 24x large. Beyond that, there is no Aurora to spin up. They have almost reached the vertical scaling limit. This customer is a subscription management customer for online streaming services. So online video streaming services, for example, Hotstar. So they maintain the customer like OTP, logins, multiple things are involved there. So what the issue was, like, for example, when there is a peak traffic, like an IPL is happening or a Super Bowl is happening, what happens is when the number of users increases, the pressure on the database increase with respect to the writes. That means they have to generate the OTP, send it to the customer, and update it back. This was a major thing. And even with 24x Aurora, as everybody knows, by design, Aurora cannot change the redo log file size, which was the major bottleneck that happened to have a write scaling issues. And even with that, they cannot scale it. And with the uncontrolled storage size, for example, they also have a huge number of size. That means they have a size around 15 terabytes of data, and IOPS was uncontrolled. That means they are spending huge on the just for maintaining this Aurora cluster. And slow DDLs, again, DDLs were very costly in their use case. They cannot even take a single minute of downtime, and heavy database cost, obviously, with that. Okay, so we migrated and they came to us, like, the major was the write bottleneck. Okay. So they came to us, we analyzed their schemas, and we suggested to them to move towards TiDB. We migrated to TiDB, just as simple as that. We made it TiDB as a replica for the current Aurora instance, and the results were again astonishing. Again, the scalability was superb. Performance was completely achieved with the distributed architecture, and again, the size was reduced from 13 terabyte to 2 terabyte, and they had the highest level of availability. So I'll just share a small snippet from the load testing perspective. So if you mention the scale, right? So this is the scale what we achieved with TiDB. That we were able to scale up to 2.59 million QPS with a P99 latency less than of 20 milliseconds. And also we were able to reduce the infra cost by 30% comparing to Aurora. And for the same test, we wanted to do it in Aurora. Obviously, the Aurora has failed. That means the latency was very higher and application was not able to complete its operation. That failed completely, miserable. And next We'll discuss about the third case study and the final case study. This is again a very interesting use case what we have worked in MyDBOps. So this customer is an SaaS-based chat platform. So they provide chat as a service to their customers in across the globe. So they have 4 regions of operation. Uh, Initially, when they came to us for a consulting, they were on RDS, master slave architecture. We optimized them. It was working fine for a certain period of time. After that, they had again the scaling issues. Then they moved to MySQL InnoDB cluster. This was a very heavy machine. They were using like or 7G. I think it's 8x large machine. 3 of them for their master, secondary, and also they had a separate backup server. And on top of the InnoDB cluster, they have 2 proxy SQL to balance the connection. Okay, so to say more about the customer, as it's a SaaS platform, they provide yeah, for per customer they'll have a database, and in the database they have around 48 tables per region. The largest region I have mentioned here, the largest region, the largest region has around 15, close to 15 to 16,000 schemas, uh, tot- uh, counting to around 7K tables, that is more than 7 lakhs table was present in a single cluster. So you can see the metadata scale at which it was running. So as you know, the chat application is unpredictable. For example, when there is a bulk of users coming in and they do their activities similar to on WhatsApp, uh, the MySQL stalls, that is InnoDB cluster stalls completely from operation. The updates become very latent, and they have to do a failover availability. They have to restart the cluster to again fix it. It was causing an unintended downtime and application failures. So this is the problem statement. Then we evaluated TiDB for the use case because it's a quite a new use case. So we have done the POC for around 3 years, migrating all their databases or schemas at scale, and we created the TiDB cluster with a reduced. Means, for example, they were using 8x large. Our TiKV size was just 4x large, and the storage was again optimized from 4 terabytes to in 5 GBs, thereby reducing the they were close to spending around $4,000 per month for a single cluster in a single region. Post IDB migration, they have reduced around $1,500 on their monthly spending. Okay, so they were spending around $3,000 or $2,500 odd, thereby providing more scalability and resiliency to their workload. Okay, with this case studies and real world scaling, I'll just close my talk. Any questions you have?
Thank you, Kabilesh, for sharing such valuable insights on scaling TiDB for large scale applications. It has been a fantastic session packed with real world experiences. We hope this session has given everyone a clear understanding of how TiDB can help your business overcome database challenges and scale effortlessly. And for those of you who might be new to us, MyDBOps is a leading database management and consultancy provider founded in 2016. Over the years, we have had the pleasure of assisting over 800 happy customers. We specialize in providing comprehensive consulting and managed services for a wide range of databases, including MySQL, MariaDB, MongoDB, Postgres, TiDB, and Cassandra. If you have any further questions or would like to explore how MyDBOps can support your database needs, feel free to reach out to us at info@mydbops.com or visit our website mydbops.com. And we will be sharing the webinar recording in the upcoming week, so stay tuned for that. Lastly, I would like to remind everyone to subscribe to our YouTube channel for more insightful content, including recording of past webinars, technical tutorials, and updates on upcoming webinars. Thank you once again to all the attendees for making this webinar a success. We look forward to seeing you at our next MyDBOps webinar. Have a great weekend. Thank you.